Okay, hello everyone. So we are starting a new topic, new section. It's mainly about liquids. So there's many topics we're going to discuss. Some are brief topics and most of them you can refer to your textbook and understand. Some have certain math equations, so we'll get into some details over there. So basically the topics we will be discussing different phases of matter, key terms like density, pressure, and something called Pascal's principle that deals with the liquid pressure. Buoyancy talks about floating objects, when something is floating in a liquid. A term that explains this situation is called buoyancy, so we're going to talk about that. Archimedes principle, you might have heard this name before. Again, it's about floating things, why things sink, why things float, how density comes into play. All that is described in Archimedes principle. And then finally we'll talk about something called Bernoulli's equation. So that's the plan for this chapter. So let's see, phases of matter. So phases of matter. So the state of matter can be divided into main categories. By looking at using physical observations, we can say that there are three main categories: the solid phase, liquid, and gas. So solid, when we say solid, the matter has a definite shape, a definite volume, right? Or a definite shape and size. So shape and size is fixed. So for an example, if you think about something like, a tennis ball, right? It has a definite shape, it has a definite size. Another example would be an ice cube. So something like this. Liquid, another phase of matter is liquid. Doesn't have a definite shape but does have a definite size or a volume. So liquid means, like, if you think about a glass of water, so this amount has a definite volume, has a definite size, but if you put it in a different shaped jar, something like this, it will take this shape, right? So the shape changes. Liquid doesn't have a fixed shape, and this is simple stuff, you guys know this. And then come to gas, or the third state of matter. Let's say we have water vapor, H2O. If you put it in this kind of container, it will take the entire space of this container. And if you put it in this shape of a container, some container like this, different shape, a different volume, still it will take the entire volume. Now the distance between the gas molecules changes here, but still it will fill up the entire volume, right? So liquids have only a fixed size or a volume. Gas won't have a definite shape or a size. Okay. And also we define something called the fourth state of matter. That's called plasma. You might be familiar with the term plasma, plasma TVs. That is ionized gas. So it's a gas but ionized. Like you can have oxygen in the form of gas, and if you ionize these oxygen molecules by, let's say, removing electrons or adding couple of electrons, or it can be ionized hydrogen gas. So that's ionized gas. Now, how do we go from one state to the other? The best way to explain this is by, you can say, by changing the temperature. Like, imagine this is a cube of ice. You increase the temperature, you heat it up, it becomes water, right? It becomes liquid. So add temperature, right? Add heat, or add heat energy. Here you have water, ice becomes water. You add more heat, becomes water vapor, H2O gas, right? And if you add a lot more heat, you can increase the kinetic energy of this H2O molecules, and at some point electrons, you can get rid of electrons from the molecule. Right? You can remove couple of electrons, you have ionized H2O, and that is called the plasma state. Plasma is a very naturally we can see plasma in, like, for an example, our sun has hydrogen plasma in it, ionized gas. In laboratories you can create plasma. In certain industrial applications like plasma cutters, they use like oxygen plasma, like that. Has many advantages, like you can form them into different shapes. Like you can contain plasma using magnetic fields, so you don't need a container to contain them. You can have a strong magnetic field and contain the plasma because it's ionized. So as I said, certain things included in this chapter you need to do your self study. A lot of simple reading involved, so I'm not gonna go over those, but I will tell you where you need to study by yourself, do your self study. So this is one area, phases of matter. I want you to give it a try. Use the textbook, the PDF I have copied, and have an idea, specific properties, some examples of these different phases, and how heat, what it does to change the state, and key terms involved in this process, like specific heat capacity, latent heat, what these things mean. So have like a little general idea about this section. All right. So next thing, let's move on to another key term, which is density. So let's go here. Density. Alright, what is density? Density is defined as the mass per unit volume. Density, we use the term this is pronounced as rho, Greek letter rho, it looks like letter P. It is mass of the object divided by the volume. So density, here we have mass in kilograms, volume in meter cubes. So you're dividing kilograms by meter cubes. So this gives the unit of density, kilograms per meter cube. Right? So if you explain this in a sentence, this will be density equals mass per unit volume. Density gives us an idea how compact the substance is. Like for an example, piece of iron, let's say Fe, iron. The iron atoms, right, are tightly packed close to each other, like this. if you take a piece of wood, same size, let's say you take like a exact same amount, same volume, the molecules inside, there's more space between them. Right, the gap is bigger in wood. Iron tightly packed, there's not much space between these atoms. So mass per unit volume, if you take a unit volume, let's say you cut a piece like this, a unit volume of this iron, and the same thing you do like this, there's more atoms inside this than wood, right? So more mass contained in a unit volume. There's less mass, there's more atoms, there's less atoms. So if you take a unit volume, this mass is bigger, this mass is small. So that's the idea of density. So therefore this thing has a bigger density, this thing has a smaller density. Alright, so so let's try an example. Question is, let's say, alright, let me take a minute and find a good question. Alright, hold on a second. So the textbook has a table in that chapter. It contains a list of densities of commonly known substances. So I'll give you a few examples. Aluminum, the density is 2.7 times 10 to the 3 kilograms per meter cube. Another common one, let's say iron, is about 7.8 times 10 to the 3 kilograms per meter cube. Another one, let's see, water, 1 times 10 to the 3 kilograms per meter cube. Now when we talk about densities, it's very, very important to mention at what temperature, because density is temperature dependent. When we increase the temperature, kinetic energy of molecules increases, so they increase the space between them. So what do you think going to happen to the density? Same amount of atoms, like for an example, let's say we take a piece of iron at some temperature like 20 Celsius. So these molecules have certain space between them. So we measure the mass, we measure the volume, we divide mass by volume, we find the density. Now we increase the temperature, let's say we increase it to 200 Celsius. So what happens is the space between molecules increases. So the whole thing expands. That's what we call expansion. Right? The space between the molecules increases. But it's the same number of molecules, right? The number doesn't change. So it's the same mass, but volume is bigger. Now, if you find the density, mass divided by a bigger volume, you have a smaller density. This density is bigger, this density is smaller. So that's the idea. As temperature goes up, volume increases, density increases. So therefore, whenever we talk about density, we have to specifically mention at what temperature. So for most of the density numbers, we take the standard temperature either at 0 Celsius or 20 Celsius. So the numbers I am giving you is at 0 Celsius, with one exception, this. Water is different. Water has this number at 4 Celsius. it's a different property of water. It's a very interesting property of water. It's chemical properties. Because of the particular shape of the H2O molecules and how the charges are distributed in that molecule, it gets this specific alignment and gives the highest density at 4 Celsius, and it changes with temperature the opposite way. If you cool it down, actually the density decreases. Like for most of the substances like iron or aluminum, the solid has bigger density than liquid, right? But for water it's different. Ice has less density than water. Ice floats on water because of this particular molecular structure of water. So here's another thing. Read up about it. It's an interesting thing to study. It will be useful for you in your chemistry class also. So just read more into this, why water behaves different from the other stuff. Alright. Okay, so let's move on. Alright, so let's try 1 or 2 examples. Example number 1. We have a rectangular piece of, let's say, aluminum. This is aluminum, and the dimensions of the sides, let's say this side is 20 centimeters, this is 10 cm, and this is also 10 cm, the 3 sides. Question is, what's the mass? So how do you find this? We can use the density to calculate mass. We know that for aluminum, from the table we can find density is 2.7 10 to the 3 kilograms per meter cube. So how do you find the mass? We know that density equals mass divided by volume. So therefore mass is density multiplied by volume. Remember, these units should be in standard units, kilograms and meters. So let's convert the volume. Let's find the volume in meter cubes. So the volume is, we know that width, length times width times height. So length is 0.2. I'm writing everything in meters, times 0.1 times 0.1. Now mass is density times, so 2.7 times 10 to the 3 multiplied by this number, 0.2 times 0.1 times 0.1. Okay, so a lot of decimal points. I'm going to use the calculator. I get 5.4 kilograms. Alright, so that's a simple example. So let's try another one. This time let's say we have a solid sphere, alright, with, excuse me. Okay, so let's say we have a solid sphere made out of some unknown material, and let's say the radius of this thing is 5 centimeters, and mass, let's say 10 kilograms. Question is, what's the density? Alright, how do we do this? We know that density is mass divided by volume. Now we have the mass, we need to figure out what the volume is. Now this is a sphere, radius is given, so how do you find the volume? Volume of a sphere is pi r cube. So let's plug the numbers. 4 pi times r cube. So this r radius is in centimeters, so we have to make it into meters. 0.05 cube. Okay, so let's see what the volume is. So we get a very small number in meter cubes. That's understandable. This is a small sphere. So I have 5.23 times 10 to the negative 1, 2, 3, 4. 10 to the negative 4 meter cubes. So then density equals 10 kilograms over 5.23 10 to the negative 4. Density equals, let's see, 10 divided by 5.23, 1.9, 1 times, becomes 10 to the positive 4. So if I check the chart, I would say this is somewhere like the density of gold actually. Can write it this way, 19 times 10 to the 3 kilograms per meter cube. And if you check density of gold, actually it is quite close to this. Okay, so by measuring the density we can actually figure out the unknown substances sometimes, because density is unique to the material. Therefore, by comparing different densities, you can distinguish different materials. As a matter of fact, in certain industries, like in gold industry or in gem industry, to find the most purest substances, they check the density. Alright, okay, let's move on. Okay, so we did 2 examples. Now I want you guys to again do a little self-study. Think about different shapes, like what if it is a cylindrical object? How do you find the volume of this? And then try a little example by yourself. What if it is a cube? Now we worked on a rectangular. Oops, why the pen is not working? Alright, there you go. Cube-like object, how do you find the volume? So all sort of these interesting questions. What if it is a cylinder with some area missing inside? How do you find the volume of a hollow cylinder like this? What if it is a sphere but it's only a shell, that inside it's a cavity? So how do you find the volume of this? So these are some interesting questions you should look into. Alright, okay. Next topic I want to talk about is specific gravity. Now the term, this word gravity is kind of misleading. It has nothing to do with this gravity we talk about, meters per second squared. This is also a density term. The meaning of specific gravity is actually, it's the ratio of density of something to the density of water. So specific gravity of a substance is, let's say, specific gravity of iron is density of iron over density of water. So this is how we define specific gravity. Whatever the density, we divide it by density of water and we call it specific gravity. Why we select water? It's easy, it's 1000. right? So therefore we know that density of iron from the table is 7.8 times 10 to the 3, or you can say 7800 kilograms per meter cube. Density of water is 1 times 10 to the 3, or just 1000 kilograms per meter cube. Specific gravity of iron is density of iron divided by density of water. So 7.8 10 to the 3 divided by 1 times 10 to the 3 gives you just 7.8. And this thing doesn't have any units because units cancels out. It's the same unit, they cancel out. So that is specific gravity, right? It's a way of comparing different densities without worrying about these decimal places and all that. So specific gravity is much simple. It's just the ratio of density to density of water. Okay. All right. Let's move on. All right. So the next topic I would like to discuss is pressure. Pressure we denote it by capital letter P, obviously, right? Okay, now when we talk about pressure, we describe pressure in general, like what is pressure? When you apply a force on something, on some surface, that force applied on the surface, depending on the surface area in contact with the force, we can define the pressure. Now that is defining pressure in general. When it comes to liquid, we can modify it unique to the liquid, and we can talk about liquid pressure. There's pressure due to a gas. You might learn this in your chemistry class. So let's see the general definition of pressure first. Pressure is defined as force per unit area. So pressure equals force divided by area per unit area. Per means you're dividing it by whatever the quantity next. So force divided by area. Force is measured in newtons. Area is measured in meters squared. So newtons divided by meters squared gives us the unit of pressure, newtons per meter squared. Alright. So this is the general definition of pressure. So let's try an example. Let's say this is a wall. Alright. So you are pushing this by applying a force. So this is your palm, this is your hand. Alright. This is the person, not you, somebody pushing it. So applying a force on the wall, and to find the pressure acting on the wall, we need to know this contact area, this area. What is this area? Right? So let's say you are applying a force of 100 newtons, and the contact area, if I generalize it, make an estimation, area of your palm, probably I would say I can approximate it by like a rectangle, 10 cm by 20 cm maybe. So what's the pressure? Force divided by area. 100 newtons divided by the area. Area is the product of the two sides, so 0.1 times 0.2. So let's take the calculator again, let's do the math. 100 divided by 0.1 divided by 0.2, I get 5000 newtons per meter squared. That's how you find it. This is how you find the pressure. Another unit, another name for this unit, newtons per meter squared, also called pascals. 1 pascal is equal to 1 newton per meter squared. Alright, so this is something to keep in mind. We commonly use both units, pascals and newtons per meter squared. So that's pressure. Alright, let's try another example. Let's say a person standing. So here's a person standing on the ground. What is the pressure this person exerting on the floor? So how do you find that? We need to know the mass of the person, let's say 50 kilograms. We need to know the contact area between the person and the floor. So to make it little simple, let's say standing by one leg. So here's the other leg, right? Standing on one leg. How about that? So if we know the contact area, we know the weight of the person, pressure is force divided by area. If it's 50 kilograms, so that is 50 times 9.81. That's the force applied. Let's say his area of his foot is same as area of his palm, so that is 10 times 20 centimeters, so 0.2 times 0.1. So what's the force, what's the pressure this time? Well, you guys can do the math. 50 times 9.81 divide by 0.1, 0.2, we get 24525 pascals. If the person is standing on both feet, the pressure will be half of that because area will be doubled, right? So by changing the area, you can change the pressure. If the person is standing like this is the floor, this is the bottom of the foot, right? Let's assume that it's flat. Okay, he's wearing shoes which are flat shoes, flat bottoms. The entire area is applying force on the surface, so it gives certain pressure. What if the person wearing something like heels, so something like this, I don't know. Now the area is really small, this little bit and this little bit, right? So area gets smaller, pressure goes up. So if somebody is wearing very sharp heels and if your floor is really new and expensive, think twice. Okay, alright, let's move on. Okay, so this video is already more than half an hour, so I'm going to stop right here, and the next topics will be coming in the next video. So we're going to talk about liquid pressure, and there's a lot of topics in this chapter, so I'm not gonna spend too much time and make the videos really long, but I'll try to keep it short, and I want you guys to do the reading and get all the background information. Alright, okay then, thanks.